I will continue talking about the recrystallization technique, which is used in an organic chemistry lab. And now we will talk about the case of purification of compound A from an impurity, which is called B. And this is basically the main reason for using recrystallization, which is removing impurities from a compound. So the principle is that the impurities usually exist in a small amount in a compound. And again, there's another principle which I talked about before in the previous video, is that molecules of the same compound have high tendency to stick together. So usually molecules of the same kind will always try to stick together, stay together, and they will try to keep all the other molecules which don't belong to the same compound out. Based on these two principles, we will be able to use recrystallization to remove impurities. So again, in this Erlenmeyer flask, we have a solution, a compound which is compound A, and then we have some impurities which are called B. Now, upon heating compound B, compound A, and the impurities will both dissolve. Now, once we start cooling the whole solution, compound A, which exists in a large amount, will start to crystallize first. So remember, the amount of B, which is the impurity, is very small. That's why it's not going to form crystals. It will stay in the solution. Whereas compound A, which exists in high amount, it will start to form crystals. So B will remain dissolved in the solution, whereas A will form the crystals or the powder. Crystals of A also, because of this principle, which is their tendency to try to stick together, will try to stay together, and they will prevent the impurities from entering their crystal structure. Based on this, after filtration, upon filtration, compound A and compound B can be separated. So compound A, which is the solid now, which is the crystal now, will stick to the filter paper, whereas compound B, which is the impurity, will go down into the filtrate. And this is how we separate compounds by recrystallization. So recrystallization is a technique which involves dissolving the solid into a hot solvent, and then after that cooling it in order to force it to crystallize, and that's why we call it recrystallization. So it is dissolving followed by crystallization. Once the recrystallization process is completed, the crystals will form and the impurities will remain dissolved in the solvent. Now, experimentally, what are the different steps that are usually done in a recrystallization process? The first step is choosing the solvent. You have to choose a solvent which can dissolve your compound, and it should be a poor solvent at room temperature and a good solvent at high temperature. So whenever you are given a couple of solvents and you are asked to choose the best solvent for the recrystallization process, you have to make sure that this solvent has very low solubility for your compound at room temperature and a high solubility at the boiling point of the solvent. So always try to choose the best solvent which has the biggest difference between the room temperature solubility and the high temperature solubility. So this is the best solvent. The second thing is that you have to be careful to choose the solvent which doesn't react with your compound. And this is something which you don't have to think really about it right now. That's basically something which we do in research labs. The second thing is that it shouldn't solidify upon cooling. Usually, as you will see later on, once we finish the recrystallization process, we cool our solution. So you have to make sure that your compound, your solvent, have a melting point or a freezing point that is really below minus 20 degrees in order to avoid the solidification, in order to avoid transforming this solvent into a solid, and this will ruin basically the whole process. It should also have a low boiling point in order to be able to easily remove it from the crystals. The second step is that once you choose the solvent, you have to dissolve your solute in the minimum amount of solvent. So basically, you have to avoid adding too much solvent, otherwise the amount of crystals that you will be able to get back will be very small. And to add the minimum amount of solvent, you have to do this. You have to add a small amount of solvent to your solute, to the crystals, to the solid, and heat it until boiling. And then start adding small amounts of the solvent while stirring the whole solution. And we keep doing this until we get a clear solution. So again, we have our solid, which is dissolved in this, which is here. We add a small amount of the solvent first. We start to heat it and to shake it. And if the solid completely dissolves, that's fine. If not, then we add a small amount of the solvent and we keep heating. We keep adding small amounts of the solvent until we get a clear solution. And in this way, we can make sure that our compound was dissolved in the minimum amount of solvent. Now, sometimes some impurities will not dissolve. So even after adding a big amount of the solvent, some of the impurities will not dissolve. In this case, we do something which is called filtration through gravity filtration, and it should be hot filtration. So make sure to say hot filtration or pay attention to hot filtration. So it's not a regular gravity filtration, it should be a hot filtration or a hot gravity filtration. Again, whenever you have impurities which don't dissolve at all, even after heating for a long time, you have to do something which is called hot filtration. And in gravity filtration, we use a short stem funnel. This is called the short stem funnel. So it's a funnel which is short stem, and then we add this filter paper, and we call it a fluted filter paper. You will see this in the lab, how to make this fluted filter paper. And it should be a hot filtration, which means that before adding your compound, you add a small amount of a hot solvent in order to make sure that the temperature of the funnel and the temperature of the filter paper is high enough to avoid something which is called premature crystallization. Again, to re-explain this, so I already have some impurities which didn't dissolve. What should I do? I should do something which is called hot filtration. What is hot filtration? So I prepare this. I bring an Erlenmeyer flask or another flask, a short stem funnel, and I add a filter paper to this. Now, since I want something which is called hot filtration, I add a small amount of the solvent which is really hot, and this is going to increase the temperature of the filter paper. And the reason is why I'm doing this is that if I added my compound, my solution which contains my compound, to the filter paper and the filter paper was cold, then some crystals will stick on this filter paper and I will lose some of my compounds. To avoid this, usually we use something which is called hot filtration. Step 3, once your solution is clear, once you have removed all the impurities, now you have to cool the solution. So you have to cool it. Now, you can either cool it slowly, so just leave it aside on the bench for some time, and it will cool down slowly, and this is the best thing because it will help in getting the best type of crystals. Whereas if you use fast cooling, let's say you removed this hot beaker and you put it in an ice bath or in the fridge, then in this case the crystals that will form will usually be very small, like a powder, and they will have lots of impurities. So always slow cooling is better than fast cooling. And of course, once you leave your beaker aside, avoid shaking it, don't disturb, because shaking it again may cause the crystals to form quickly and then the impurities will be inside. If the crystals didn't form after some time, usually one of the things that we do in the lab is that we scratch the bottom of the beaker with like a spatula or anything, and this is something which is called sealing. And what we are doing basically is when I scratch the bottom of the beaker with like a stirring rod or a spatula, some glass pieces will appear here, and those glass pieces will help the crystals to grow on them. So this is called sealing, and this is one way of forming crystals if the crystals didn't form by themselves. Once the crystals are formed, in order to increase the yield of the recrystallization process, you can put the beaker or the Erlenmeyer flask or whatever flask you are using in an ice bath to increase the yield. Fourth step is the filtration step. So once your crystals are formed, then you have to filter them so to separate them from the solvent which contains the impurities. We usually use something which is called the a vacuum filtration. So we have an Erlenmeyer flask which have a side arm, and then we have a vacuum pump to create some vacuum here. This vacuum will help the solvent which is poured here to go down quickly. So this is a fast process. This is called suction filtration. In suction filtration, we use this funnel which is called the Buchner funnel instead of the short stem funnel. And once the crystals are collected on the filter paper, usually we wash them with a small amount of the cold solvent just to remove some of the impurities if they are still sticking to these crystals. Finally, once you have the dry crystals, you can weigh them to calculate the yield of your recrystallization process. Now, what's the difference between vacuum and gravity filtration? Vacuum filtration is usually fast, whereas gravity filtration is slow. In vacuum filtration, we use the Buchner funnel, whereas in gravity filtration, usually we use the short stem funnel. Vacuum filtration is usually used for large quantities because it's very fast, whereas in gravity filtration is mainly, or it can be used only for small quantities. Usually vacuum filtration will give you a dry solid, whereas a gravity filtration will give you a wet solid. So once you collect the solid on the filter paper, in this case it will be dry, where here it will be wet. And finally, usually if you want to retain the solid, we have to use a vacuum filtration. If we want the filtrate, usually we use gravity filtration. And this is of course a scheme which shows us the difference between this is the gravity filtration setup, and this is the suction filtration or vacuum filtration setup. Usually in the recrystallization process, you will be asked to calculate the percentage recovery, which is the amount of solid that you collected at the end of the recrystallization process divided by the initial amount that was given to you at the beginning of the recrystallization process. And this is again one of the questions that you can practice to solve and find the percentage recovery.